potential difference exists between the 2 points of electric field. Now, electric field can be created only by presence of electric charge. If there is no electric charge, there will not be electric field. That means electric charge is the source for creating any potential difference. Okay. Now, we come to that term. Here is a electric charge which has dimension or which has size q. Now, from here, this is the point A and this is a point B. Okay, this distance is RA and this distance is RB. Because of this Q, there is electric field all around. Everywhere its electric field can be experienced. Now, I want to find out the potential difference between point A and point B. Point A is at RA and point B is at a distance RB. Okay. I know the basic formula. The basic formula for potential difference is whatever work I have to do going from B to A. So, if I find that, then I will know the potential difference from A to B, that will be equal to work done from B to A up to A from B divided by charge carried. This is my fundamental formula on which I will be working. Okay. Now, I place one charge Q here and it experiences a force. No, not that way. To start this R is small, here electric field will be stronger. This R is large, here electric field will be weaker. There is a change in electric field. Since uniform electric field is not there, I cannot multiply force with the distance because distance is there of course, but force everywhere will change. And we know the formula for force is Q into E, and this E is changing from this point to this point. So, at every point force will be different and distance will keep on changing. The force is changing, therefore, we cannot multiply force into distance to get the work done. But I want work done to be calculated. What do? I take help of calculus. How do I take help? From this point, I take any one point, let us say a general point which has got a distance x. Okay, P. P is a general point. Electric field at P is Q upon x square 1 upon 4 pi epsilon naught. This is electric field at P. You know the formula 1 upon 4 pi naught charge upon square of the distance. Okay, this is electric field. Then what will be the force? I start my journey from point P and I travel a very small distance, this distance dx. Dx is such a small distance that it can be termed limiting to 0. So, if it is so small, then I can presume that there is no change in the force from this point to this point. And if there is no change in the force, then I am permitted to use the formula that work is equal to force into displacement. This we can use only when the force is not changing on the way. But dx is so small, we assume that force is not changing from this place to this place. So, we are allowed to use this formula. Okay. Then, this is electric field, force on test charge, force on test charge Q. Force on test charge Q is F is equal to electric field multiplied by charge. And what is electric field? This is electric field. 1 upon 4 pi epsilon naught q upon x square multiplied by this charge q. This is the force acting on the charge q which I place here. Now I displace it with a little distance dx, then dx towards A. How much will be the work done? The answer is a very small work done, because the distance is very small dx. So work done will also be taken as small work done, dw. So this dw is equal to force. This is the force 1 upon 4 pi epsilon naught q upon x square. This is to be multiplied by dx. This is equal to, okay, this is dw work done for such a small distance dx into cos 180, because this force due to plus q on plus q is in this direction force, and I am doing dx displacement in this direction. So there is 180, so cos 180 is equal to minus 1, and this we can write as dw is equal to minus 1 upon 4 pi epsilon naught q upon x square dx. Okay, if this is the work done, small work done, we get the formula for this. Now we want to calculate the total work done from distance RB to distance RA. What are these values for? These are the values of x. Once we make x as RB, then we make x for RA. So total work done up to A from B is equal to integration B to A of what? This dw. This is, this I should write RB to the distance RA, and integration is to be done for 1 upon 4 pi epsilon naught into q upon x square into dx, which is the value of dw. So dw integration is total work done. Now this is equal to, this is constant, all will come out. So q upon 4 pi epsilon naught and integration from RB to RA, and here we get 1 upon x square dx, that means x to the power minus 2 dx. Now here we do the integration of x to the power minus 2, and integration of x to the power minus 2 is increase the power by 1, x to the power minus 1 divided by minus 1, that is integration done. Work done up to A from B is equal to q upon 4 pi epsilon naught, and that is x to the power minus 1 upon minus 1, and this has got limit RB RA. And is there any sign negative? Yes, negative. Now this minus 1 we take out, and this minus will become plus. So this is equal to q upon 4 pi epsilon naught, q upon 4 pi epsilon naught. Now it is x to the power minus 1, that means 1 upon x. This is RB RA. Here q upon 4 pi epsilon naught. This is 1 upon Ra minus 1 upon Rb. Okay. So, what we are doing? We are calculating work done from B to A. Always remember, this is up to. From B to A, the work done is this. If this is the work done from B to A, on how much charge? The answer, this is the work done on a small test charge Q. Then how much is the work done per unit charge? The answer is work done per unit charge is work done AB per unit charge Q. This Q I transfer on this side. This is what? Q is equal to, then we have Q upon 4 pi epsilon naught and 1 upon Ra minus 1 upon Rb. And this work done from B to A per unit charge is known as our definition Va minus Vb, potential difference. So this potential difference is Q upon 4 pi epsilon naught 1 upon Ra minus 1 upon Rb. This is our final notation and final formula for potential difference between 2 points. And what is the specification of these 2 points? One point is at a distance A, other point is at a distance B. From where? From charge Q. So from charge Q, the potential difference between 2 points at distance Ra and Rb, due to charge Q, potential difference between the 2 points at distance Ra to Rb, this potential difference is given by 1 upon Ra minus 1 upon Rb, this expression. So this is a very versatile and important expression which gives us potential difference between the 2 points. The very first thing we did was potential difference between A to B is work done from B to A per unit charge. Then we had a formula, potential difference, we will call it V, that is equal to minus E into dr. dV is equal to, I will write it dV. dV is equal to minus E dr cos theta, or this is E is equal to minus dV by dr cos theta. Other we had is line integral from A to B of E dl. Negative of the line integral is equal to the potential difference Va minus Vb. Now we have done another formulation, and that formulation is Va minus Vb is equal to, this formulation is related to source charge Q upon 4 pi epsilon naught 1 upon Ra minus 1 upon Rb. So A is at a distance of Ra from Q, B is at a distance Rb from Q, and the potential difference is Ra minus Rb. Okay, so far we have done so many relations about the potential difference. Now in the next lecture, so far we are talking about potential difference. Can we discuss what is potential of a single point? If I ask you what is potential of this point, then is there any such quantity, potential of one point in physics? The answer is yes. We have made such quantity, potential of a point. How do we define that? That we will do in the next lecture.